Hi, welcome to class. My name is Don LaFon, Professor Don, and this week in our A plus hardware class, we are covering our final A plus topic, which is computer design and troubleshooting. It's chapter 11. Now, what I like about this chapter is it puts everything together, everything that we've learned all semester long, including RAM, CPUs, motherboards, even the case that we put into it. Ultimately, we're going to talk about all the little pieces, how it can all be put together. The soft skill dealing with irate customers, which is something unfortunately you're going to run into if you're a tech. So let's go ahead and get started. I'm going to share my screen. If you're here with me live, please hold your questions until the end of the presentation. If you're watching it as a recording inside of our A plus classroom, Canvas classroom, please ask questions in the help discussion forum. And if you're watching this out on YouTube, first of all, welcome. I'm glad you found my class and thank you for watching the presentation. If you have any questions, please ask in the comment section down below and I'll be sure to answer those. You're also welcome to make comments down there like helpful video, or if something isn't quite right, you can point it out down there. I teach this course often, so there's always an opportunity to recreate the video and replace the one that's there if there's something incorrect or off or whatever. Just let me know. But I like to hear good stuff too. All right, so let's go ahead and pause the video because this PowerPoints are on the wrong screen. 1 second. Okay, now we get the PowerPoint in the right place. Let's go ahead and get started. Computer design and troubleshooting. All right, so we're probably going to be together for just about an hour or so. Let's get started. And this presentation covers dealing with irate customers and the soft skill, the learning process, which is just one slide, which is very interesting to just randomly throw that slide in, but I didn't make these PowerPoints. I just present them to you. And then design overview. That's where we're going to talk about building a computer from scratch. So qualities of a good technician. Soft skills. This time we're talking about irate customers. Common issues for those who, and let me give you my background. I worked for America Online. It's the company that everybody used to use to sign into the internet back 20 years ago or so. And when I worked there, I took 30,000 phone calls in a 3-year period, helping clients troubleshoot while they kept getting knocked offline on their dial-up modems. Yes, that was a long time ago, and yes, I was there through all your pain. If any of you ever had to call AOL, you probably reached me or someone just like me. And we tried our best, but sometimes customers were really irate. They were really upset when they called us because they wanted to just play online and they weren't able to because every 5 minutes they would get knocked offline and they weren't doing anything wrong. It was just probably noise on the phone line or a setup on their modem. And my job was to help them get through that. So I do have some history of dealing with irate customers, calming them down, helping them fix their problems, and sending them away happy. So I do know a little bit about this. So a common issue for those who come or to try to help or try to troubleshoot a problem over a phone is that you run into an irate customer every now and then. And what you want to do when you do is those people just want their problems fixed, right? They may just need to vent. They want to be heard. Let them vent, right? Try not to interrupt when they are explaining what's going on, but by saying, we can't help with that. You can help in some way. You want to start the process of helping. You want to start the process, if you can't finish the process, getting them to the right people. Ultimately, if it is your department that needs to help them, you want to be that person that can help. In today's world, we have in a technical environment, we have a computer screen that suggests the next thing to tell the client or next thing to check, have the client check on their computers. And that's helpful because you'll plug in what they're saying while they're venting, and then you'll verify what they say, and then it will suggest something on the screen. Now, back in the day, it was always, for me, it was always, have you restarted your computer? And the answer 9 out of 10 times was no. And I say, well, that's the first thing you should do. Go restart your computer. And then they would say, oh, but I need to be on the modem uses the same line I'm talking to you on. It's like, well, it should fix the problem. Call us back if it doesn't work, and they'd hang up. Hopefully, they would fix the problem, but I would tell them to call us back if it doesn't. Anyways, you can, like me, you can talk to many peer technicians to find out what they have done successfully or not, dealing with difficult customers. I like to recommend a joking personality. Don't laugh at them, but laugh with them about the problem. Don't blame don't blame the manufacturer of the computer or the product that you represent, but just work with them to help reduce their irritability, their why they're upset, and solve the problem. While you're dealing with irate customers, avoid aggressive behavior in your demeanor. Avoid passive behavior. Now, passive behavior involves letting others dominate you and express yourself apologetically. Again, you don't want to apologize for the company. I never said to a client, well, America Online has a problem. No, I never said that. I always said, yeah, other people have had the same problem. Let's see if what worked for them works for you. And then I jumped into troubleshooting. That's just what I did back in the day. And that's not what I did 3,000 times. It's just when they were having a problem staying connected, that's probably what I said. Practice assertive behavior. Be respectful of another person, but don't allow him or her to take advantage or dominate the situation. Stay calm and maintain your professionalism. Ultimately, your job is to make the client happy. Otherwise, guess what? They won't be your client anymore. So do the best you can. Ultimately, if you don't have any clients, you're not in business, you don't have a job anymore, you get where this is going. So the better you can be at troubleshooting clients' problems, the better chance of you keeping your job. The learning process. Now, for some reason, Bloom's taxology is presented here, and it is a way of learning that is critical to the process. Now, why this slide isn't in week one, I don't know, but here we are at the end of this presentation, and they're mentioning it. So Benjamin Bloom chaired a committee that created a classification of learning objectives that was named Bloom's taxonomy. Sorry, taxonomy. The figure to the right shows the learning process from top to bottom. Notice that creating is at the top. Employers want people who can design. Those are the folks who know all the things that it takes to be able to design. So when you are going through, maybe perhaps that's why they teach this here. I really wish they put this at the beginning of the presentation, the beginning of the semester though. But what you want to do is you want to hire people that can create. Today, we're going to talk about creating a computer from the pieces that we've talked about all semester long. They don't want somebody that has to go to the manager or go to the supervisor and ask which parts to pick and what is better, how to do it, instructions, details. They want people that can be able to evaluate options, analyze choices, apply the knowledge that they have learned without having to get step-by-step instructions, understand the situation, remember what they've learned in college or in previous example. But ultimately, all of that put together is creating, in this case, a computer, but creating a product that they can be proud of. Now, it doesn't mean it's going to be perfect, right? You're going to create something, and then you're going to get feedback, and then you're going to go through the process again of understanding what changes need to be made, applying those changes, analyzing options, evaluating your choices, and ultimately creating another product, bringing that back to the supervisor, or whatever, and getting your ultimately getting your product approved, your computer approved. In this class that we're making right now, that we're in right now, the final project, team project number 2, is to create a computer, put all the parts together that we've talked about into some sort of presentation and present it, and that in the discussion forum. If we were live, we would be presenting it in a classroom, but we're doing this class online. So you're gonna drop your presentation into a PowerPoint. Everybody has into a discussion forum, and everybody has to review your PowerPoint and to see if you covered all the material. Do you have a CPU? Which monitor did you choose? Which video card did you choose? How much RAM did you add? What software are you going to put on the computer? Microsoft Word? Sure. Microsoft Office, I guess, today. And what operating system? Is it an Apple computer? Is it a Windows computer? You get to create that because that's what the project is, and you're going to have fun with it. Let's talk about the design overview. CAD CAM and graphic design workstations. So computer, that's really the high end of the business world. Just like a gaming computer is the high end of a computer, a home use PC. CAD CAM graphic design workstations are used in manufacturing plants and by engineers and design engineers to create things. They're powerful multi-core processors. They have maximum system RAM. They have SSDs for speed for their storage. Sometimes just the operating system is running in the SSD, and maybe an M2 drive. We've talked about that. And storage is on a hard drive, a large capacity hard drive for handling all the details, all the files for supporting that computer that you're creating. Not the computer, whatever it is you're designing. Maybe you're designing a new car. Maybe you're designing a new type of motherboard. Whatever. You have to have a lot of processing power. That comes in with a multi-core processor. Anything that has to do with CAD or CAM 3D design is very demanding on the CPU. You want large displays, and I want to change the word or dual displays. I've told you I have 5 displays in front of me right now, and I'm not even doing high-end CAD CAM. I'm just teaching with them. Possible peripherals include digital tablets, scanners, plotters, and 3D printers. High-end quality mouse or another type of input device that you prefer. And what the author of these PowerPoints did was they went ahead and put an asterisk next to any specific element that is A plus cert, an A plus cert objective. So they filled out the rest of the presentation, but you have to be aware that, and I remember the A plus certification exam. In the A plus certification exam, it gave you uh, um, several different elements. And they asked what type of computer has maximum RAM, an SSD, and high-end video card, and you had to know whether that was a CAD CAM workstation or a gaming PC or a thin client or whatever. So so when you're studying, when you're considering CAD CAM, a design workstation, know that it has to have maximum system RAM, an SSD, and high-end video. A gaming PC, powerful multi-core processor, high-end video cards with maximum video RAM, and specialized GPU for crunching the numbers to display the game that you have in front of you. High-end definition, a high-definition sound card and speakers, high-end system cooling. I've told you before I have water cooling. And I always wonder where the water actually goes, because believe it or not, in a water-cooled computer, the water slowly goes away like it's evaporating, but it's a closed-end system. Where's it going? I don't know, but it's not leaking anywhere. So I've had water cooling for, I don't know, 5 or 7 years in my home, and I've never found a leak anywhere, but it goes someplace. Anyways, anybody has any solutions to that, go ahead and put it down below in the comment section on YouTube. I'd appreciate that. Um, Anyways, a large display or dual displays, quality mouse, possible gaming console if you're playing an Xbox or PlayStation type game. Headphones with the microphone so you don't keep your spouse awake or your girlfriend or your parents awake when you're gaming at 3 o'clock in the morning, and maybe some 3D glasses or a headset, right? That those are all found on a gaming PC. Audio, video. Oh, and specifically, again, for a gaming PC, it's a high-end video card with maximum video, high-end definition sound, high-end system cooling, and an SSD. For audio, video editing, you want a specialized video card with maximum video, specialized audio card with speakers, very fast or large capacity hard drive, a dual monitors, powerful multi-core processor, large amount of system RAM, quality mouse, possible digital tablet or scanner. And those are the key components of an audio video editing machine. The next one, and that's it. Those are the three that they talk about. Make sure you look in the book, the textbook, to find out if there's any additional computers. I thought for sure that they had a thin client, and let me take a look. I'm gonna pause this just for a second. 1 second. Okay, they do have thin client, and it's actually in my presentation in a couple of slides. I knew it was there. I just didn't want to make sure I lost the slide or something. It's just seems like it's a little out of order. Because they're jumping into network attached storage, this is an NAS drive. It can be separate. That's what this is. There's multiple drives in a storage device, and I have one. I can show you a picture of mine in just a second. But I'm really happy with the client. Hang on. All right. So normally I don't call out companies specifically when I'm talking about products, but I do want to call out Mediasonic because I purchased a Mediasonic NAS. I'm not sure if it was this one that I have, but allows me to run RAID 1, RAID 0, RAID 5. And I love this drive, but not only do I love the drive, it's worked fine for years. But I had a problem with it where I actually, while cleaning it, which I do recommend you clean your computer components, I had a vacuum and I took the cover off of this unit here to vacuum out the inside of it, and then it tipped on the table and all the drives came out of it. Well, back in the day, RAID drives, I have 4-bay RAID, for the RAID location, the hard drive location made a difference. Back in the day, it made a difference, and so I hadn't labeled the drive. So right now, I'll tell you a good idea: put a number on each one of the drives in your NAS, 1, 2, 3, 4, and if you replace one of them, you just replace 3 with a new 3, right? So it's good to do. Because I never pictured myself dropping all the drives out of here. But when it happened accidentally while cleaning it, I contacted the company, and the company was fantastic. The guy said, "I don't know, let me check," and he actually built a RAID cabinet with multiple drives. They took out all the drives, and he actually put them all back in. And then commented, then let me know. I didn't ask him to do that, but the customer support was so fantastic that he convinced me that it was okay to just put the drives back in, and that it would be fine. And I had the backups of a lot of important stuff on that drive, but I took his word for it and I put them back in there, and sure enough, it worked fine, and my RAID cabinet was back up and running again. If it mattered, like it did back in the day, if it mattered what order they were in, the drive would have reconfigured automatically, and it would have wiped everything out. So it was a big deal. And hats off to Mediasonic. They don't pay me to talk about them, but excellent customer support needs to be recognized. and they really helped me out in a time of need. So I really appreciate that. But that drive, what it allows you to do is it allows you to store content, whether it's files that you create for school or work, movies, videos, your music, whatever you have on your pictures of your family, whatever you have on your drive, you can not only have it on your computer, but you can store it on one of these external uh, NAS storage devices. Now, you can also, we talked about RAID 0, 1, and 5 earlier in the semester. You can also build a RAID inside of your computer. Of course, I've mentioned this before. The problem with that is if you get a lightning strike and it blows through your UPS and it fries your computer, well, your backup is also that NAS. Your RAID is also in the computer. By having an external RAID, you're able to disconnect it from the computer when you're not actually using it. And by disconnecting it, obviously electric can hit your house and fry all your stuff, but something that's not connected to the wall, make sure you disconnect the power, as well as the USB connection or whatever however you're connecting it. Could be FireWire, it could be USB-C or whatever. Make sure you disconnect it if you're concerned about, if you live in a high electric area, a storm area like I live in, losing power is not unusual. Okay, getting hit but fortunately I haven't been hit by lightning yet. Now to continue, virtualization workstations. Now, virtualization workstation means two things. A workstation that has at least one operating system in its own virtual machine that is separate from the host operating system. And two, a workstation that uses hardware and software virtualization techniques to provide an end user with a controlled workstation environment. Now, where this comes into play is when you are in the A+ software class, we talk about multiple operating systems. We talk about Windows 7. The A+ certification test has Windows 7 on it. Currently, in the summer of 2022, it has Windows 7 on it. It has Windows 10 on it, Windows 8 on it, and that's it. It doesn't have 11. It no longer has Vista, thank God. So when you're trying to learn these multiple operating systems the uh, in the A+ software class, you don't want to have multiple computers each running a real operating system. So what you do instead is you use the hypervisor that's in the Windows environment. I apologize, I'm not up to speed on Apple, but we have Windows computers in our classroom environment, and we load the hypervisor, we load multiple virtual operating systems, virtual machines, is what they're called, virtual machines, one for Linux, uh, one for each one of the different Windows operating systems. And as we go through the content in the course, we use the different virtual machines. Now, these virtual machines only they work in a protected environment. I consider it a sandbox. You may have heard that term before, but call it a sandbox because you can play all day in the sandbox and ultimately never hurt anything. That's true with an operating system that runs in a virtual machine. If you delete the wrong thing, you format the hard drive in the virtual machine, you didn't lose anything except for the sand in the sandbox, because you're not deleting the real operating system that's on the real computer. You're deleting a simulated operating system that's in the virtual workstation. Now, in today's world, I just gave you the example of number one, but in today's work environment, you may have a workstation that everything on the computer is run by an instance of the operating system that is actually running on a different computer. We call that thin client, so we'll see it over the next couple slides. We talk about it. But ultimately, instead of a company having to load replace their computer every 3 years because they're out of date, and with new software that would with new hardware that can support the newest and greatest programs that are running, and new RAM and all that good stuff. What they do instead is they just put a minimal operating system with the CPU and a very small hard drive, and just minimal RAM on your at your desk, if you will. And then the processing power, everything is run off of the servers that are located in a different part of your company. And your computer has very little to it. That way, it lasts. If even when they do have to replace it, then they don't have to replace as much because everything is minimal to be able to run the instance of the virtual machine. That's where we're going in this world, and you'll be fixing computers that are like that, probably in once you get to a company and you're working for them. They will probably have some machines that are called thin clients. Let's go on to this concept I'm talking about. The virtualization workstation has maximum CPU cores, um, maximum RAM, multiple fast, large capacity hard drives, possible SSDs, possible network storage devices. That's that's the virtual workstation. That's actually part A here, where you have one powerful computer that's running virtual machines that have lots of other operating systems on it. It has to be strong because it's running not only its own operating system. Let's say you're running Windows 10 or 11, but it also has to run on top of that. It has to run Windows 7 in a virtual machine. So that's why it still needs to be a maximum CPU. But notice it's not multiple processors. So it's not as strong as the first computer that I talked about, the CAD/CAM computer, right? But you need lots of RAM. By the way, in these instances, you allocate real RAM that's on your hard drive. You allocate that RAM to your virtual machine. So the virtual machine has RAM, it has hard drive space, it has CPU cycles. The whatever RAM you give to your virtual machine is not available for the computer to use. If you have your virtual machine open, it's using that RAM. If you gave it 2 GB of hard drive space, that 2 GB of hard drive space is not available on the main computer, on the workstation, because you've given it to the virtual machine. I hope that makes sense, right? Um, the virtual machine has a real hard drive space, a real RAM space, real CPU on the workstation, that it's kind of, if you will, borrowing it or partitioning it off into those virtual machines when those virtual machines are active. Yep. And so this is the thin client I was talking about a little bit ago. So uh, a thin client is a desktop or laptop that has a display, mouse, keyboard, and network connectivity, and runs applications from a server. The characteristics to look for in a thin client include it meets the minimum requirements for the selected operating system. It has a 1 gigabit high speed preferred network connectivity, and that's basically saying you're loading and basic applications loaded on it itself. Everything else is virtualized on another computer, and the reason why you have a high speed connection, you need a high speed connection, is because you are downloading all of the programs that are on the workstation. This guy, the virtualization workstation, you have to download those all onto the client, the thin client, because it's not loaded. Let's just take an example there. Microsoft Office, the program with Word, Excel, PowerPoint, that program can be loaded only on the virtualization workstation. And then in the instance that they create for the thin client, when you go to open Word, it has to send Word to your computer. The thin client does not have Word installed on it. That's what makes it a thin client. It's just a minimal computer that is running a virtual instance of the whatever it is that you are running, the operating system and whatever programs you're running from a virtualization workstation. I hope that makes sense. Now, a thick client computer is the most common type of desktop or laptop in the work environment. It meets the minimum hardware requirements for the selected operating system. It meets recommended hardware and software requirements for any running applications that you have. It has optional display privacy screen, like the thin client, and it has optional dual displays, obviously. And for the longest time in the college, we only had uh, one display in the labs, and I had three in my office, and I love working in my office with three displays. But when I'd have to go to just one display in the classroom, it felt like I was being so restricted. And the same thing with all the students. It's nice to have the instructions on one side on the second monitor and the project you're actually working on in front of you. That is actually usually um, a good alternative to having one widescreen monitor in front of you. But anyways, depending on the setup you have at work or in your classroom, you have hopefully at least a widescreen, if not multiple monitors. If you don't, look at your graphics cards. If you have a second graphics connection, and go buy yourself a second monitor and connect it, because you will use it. I promise you. I love having multiple monitors. Other common workstations include a home server, industrial computers, and mobile computers. Uh, Mobile computers is laptop, tablet, all that stuff that we've already talked about. Home servers, I actually know people that have servers running at home. They're dedicated computers that serve uh, their own um, web space. You can either pay a company to serve your website, or you can have your own server. If you have your own server, of course it has to be on 24/7 for anybody that's trying to get to your web page. Industrial computers are specific computers to whatever the industry that you're currently using. For example, the computers at the bank run the banking software. That's just one example of a computer that could be a high-end workstation, but probably something specific that's running specific software. You've seen them before. Anytime you go up to a computer and it's still running a white text and a black background, uh, I doubt if it's running Windows 3.11, and it's been a long time since you and I have been using that. It's probably an industrial computer that fits a specific purpose, and they don't want you surfing the web on it. They want you doing your job on it, and that's all. Go green. When you're replacing or upgrading, don't forget to recycle the old electronics and dispose of properly. Properly. Recycle. So, some big box stores accept, and I don't want to throw it out because I don't want to put anybody, but um, the major compute, as far as I know, they still do it, but the major computer sellers, such as Best Buy and Micro, what's the other one? Still has. We don't have them in Florida, but they're in Georgia. Um, I forget the name. If anybody knows the name of the other box, put it in the other big box seller of electronics. Put it in the discussion. But we only have Best Buy here in Florida. We used to have CompUSA, but they went away. But anyways, if they will probably take your old electronics, bring it to them. If you have old batteries, for example, at old batteries for your UPS, they go bad every 3 years. It's not a big deal. Make sure you buy a UPS that has a replaceable battery. That way, you can just replace the battery instead of the electronics. Those batteries can go into some of the big box hardware stores that take rechargeable batteries for drills and um, tool, uh, electric tools, right? Like electric skill saws and whatnot, and uh, I'm not thinking straight when it comes to electronic tools. A drill, a cordless drill. Everybody knows what a cordless drill is, right? That battery will go bad as well. All of my yard work is all my yard tools are all electronic and electric. And I will bring my batteries to the drop-off site in the big box hardware stores to be recycled. I'm not going to put those in the trash when they finally die. Nobody responded to my. Let me go find it. Hang on a second. So I found the name of the center. It's the store is called Micro Center. They're not in Florida, but they are in Georgia. But there's lots of stores that accept recycled batteries or recycle computer parts specifically. Call ahead before you bring it. Make sure they accept that work, and they still do. I haven't brought anything to Best Buy since I brought my VCR back in the day when I finally took it out of my living room. I brought it to Best Buy, and I was happy that they took it from me. Anyway, so they properly restore they they recycle those devices. There's lots of valuable uh, um, metals in the computers, and you want to recycle them to not have that get to your dump, your junkyard. Anyways, all right, the landfill. All right, let's keep going. Recycle. Check ahead. Make sure you're recycling it in your area because we don't want to just throw that stuff in the trash. Motherboard and associated component designs. Now, we are going to talk about the specific pieces of a computer, and you are going to do a project in my class. We're going to build one. So these pieces all have to work together. The motherboard, chipset, and CPU are all directly related to one another and should be designed in conjunction with each other. When comparing processes, consider the size of the chip, the nanotechnology. That's how we measure the year-to-year improvements. As they get smaller and faster, smaller and faster, and smaller and faster. Processor technology length is measured in nanometers in today's world. A nanometer is I don't even want to, let's see, 1 to the 10 to the negative ninth. What is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 8 zeros is a nanometer. And I had a really cool video that zoomed in on how small a CPU actually is. And when we talk about the processors on them. But that gets too deep. That's when we talked about CPUs, not necessarily when we talk today when we're all putting it together. But hang on a second. Let me. Okay, so sorry about that. I what I want to introduce now, and it's not only for you out in the internet, but also for the students that are in my class when we're talking about the project. I recommend using a website such as PC Part Picker. Now, I actually used PC Part Picker to build my personal computer, my newest computer, and it was fantastic because it only allows you to buy parts that actually work. And ultimately, you just start with something. You can start with a motherboard that you want. You can start with a processor that you want. For me, I started with my case. I had determined which case I wanted, a Thermaltake 900, and I love the case. And that Thermaltake 900 only allows certain things: the size of the motherboard, the size of the fans. I have a radiator for water cooling. Ultimately, I had to go through to make sure it would fit. I had to go through the design. Once you pick something, then you continue to walk through the steps in the process. You can see some other people's builds. and you actually start and you decide. You can start anywhere. You can start with, for example, my case. I started with the case, and I started with a a thermal take 900. So I started with this case, right? I love my case. And you don't have to buy through them. I'm sure they get a little bit of money if you do. But once you select your case, then you are able to, let's see, I want mine's white. And how do you actually select it? I forget how to select it. To select it, 1 second. Okay, it's right here. Big blue button says add. So you add that. And now when I go to choose other pieces, it's going to only allow me to choose things that fit in this case. And specifically for me, it did not allow a radiator that I wanted, and I could not understand why. And I went ahead and bought the radiator anyways. Well, I found out once I got to it that the it was a all-in-one, an AI uh, cooler, and the cord isn't long enough to reach with that runs the water to the CPU cooler. Isn't long enough to go from the top of the case to the cooler, and so I had to send that part back, and I built a custom water cooling loop instead. But you get the idea. So then you go pick a CPU and you say, well, I want the top of the line AMD, and let's just grab one. So I'm going to take let's get the most expensive one. Why not? So we can go with the most expensive one. Now we're not going to do a $9,000. The most expensive one that an average Joe like me, a teacher, can buy. All right, we're down here in the Ryzen. This is actually the one I have. So we're gonna add that guy. And then, and then now because of that, when you go to motherboard, it only gives you options that are AMD options that will have that CPU. You get the idea. It gives you a running total on the left-hand side, and then it tells you, very important, it tells you how much wattage you're going to need. So as you move through the build, you ultimately want to pick the power supply last, because it has to support whatever your tools are, right? You get the idea. So wow, that's how about that? $1,000 motherboard. So let's go with an a Asus. I love Asus. And you see what's happening, right? And because of this Asus in that case with this AMD processor, it's only going to give me RAM that's going to fit that case. When I buy a cooler, it's only going to be coolers that fit the case and the CPU. You get the idea, right? Again, PC Builder, PC Part Picker does not pay me for this ad. Maybe they should, but I really love the program. And for the project, guys, those of you that are actually in my actual class, I highly recommend that you use a program like that. Now, it's not the only program out there. Here's another one, PC Building, a builder that you can use, and it does the same exact thing. This is just another random website that I found out there that's free to use. And I believe Newegg has a PC Builder tool in it that only allows you to buy compatible tools. I mean, parts. You would think that that would be important for people buying parts online, because they don't want to have to accept returns. So if ahead of time you make sure that you buy the right CPU that fits in the right motherboard, that fits in the right case, and has enough power with the right power supply, then you're in good shape at that point. Okay. So, motherboard associated component design. When dealing with the motherboard, consider the following. The form factor. There's multiple sizes of motherboards, all the way from an ITX to a extended ATX. And I don't have a picture of that in front of me or handy, but I think we covered that earlier in the semester. Easy enough to do, to Google the different motherboard size. And you do need to know the different form factors for motherboards, not just because if you're building a computer, you need to know if it will fit in your case, but you also need to know for the A+ certification, because it asks you which of the following is the largest one, which is the smallest one. Uh, the chipset that is on the motherboard, make sure that your chipset is compatible with whatever CPU. You don't want a motherboard that's an AMD motherboard with an Intel CPU, obviously. And the size of the CPU has to fit in the motherboard, because a different nanotechnology is a different size processor. So a 14 nanometer CPU is not going to fit in the socket for that is on a motherboard that's a 32 nanometer. They all have uh, they all have sizes when you're building it. It's not sizes. I'll show you. So I just opened up Newegg because I'm not selling Newegg. They don't pay me for opening them, but I've used them before. Amazon is excellent too. There's lots of good companies to sell parts from. The one I mentioned earlier, but anyways. So all you just go to components, and then you go to CPUs, and then the CPUs, desktop CPUs, and then notice if you have Intel sockets, you've got to know your motherboard what size socket you're going to use in that motherboard, and you have to buy a CPU that fits that socket. For example, a 1200 LGA 1200, you apply that narrows down the number of CPUs that are available. And obviously a Intel AMD socket is going to have their own choices. Now AMD, some of the socket the sizes actually do fit. I think AMD, don't hold me to this, but I think anything that's I think AM3 is backwards. AM2 will fit in an AM3. I don't remember. When I was building my computer, I knew all that stuff, but it's all kind of dulled a little bit. What you need to know is you need to know that whatever motherboard you buy, you have to buy the right CPU that fits it. It's one of the hardest things about building a computer or replacing a part on a computer. Let's say your motherboard goes bad on your computer. Well, you buy the newest motherboard. Well, the CPU is the newest CPU. You're not going to be able to, you probably won't be able to buy an affordable old CPU for well, you're not going to buy the same, you're probably not going to buy the old motherboard, because the price will be higher and it won't be as good as today's motherboard. So you'll say, all right, I'll buy a new motherboard. You buy a new motherboard, and guess what? It has a new socket size for the CPU. And so you need a new CPU. It has new RAM size, and RAM isn't generally backwards compatible. So DDR3 doesn't fit in DDR2. I think DDR, um, anyways, it's generally not backwards compatible. I think the newest RAM might be backwards compatible, but I'm not positive about that. CPU cooling. Anyway, so when you have to replace the motherboard, you end up having to replace the RAM and the CPU. Now that doesn't mean you have to replace the hard drive, or you have to rerun your cooling. You might be able to use the same CPU cooling block if you have water cooling, or maybe the fan will fit on the new size cool. Normally, when you buy a fan, it comes with multiple size brackets. CPU cooling fan has multiple size brackets, so it fits on a AMD or a CPU in different models. But maybe you built your computer 4 years ago and you haven't and you didn't keep all the little different size brackets, and you're going to have to buy a new cooling fan. You get the idea. Might be time anyways if you bought your computer 4 or 5 years ago. More RAM, the number and type of input and outputs on the back and on the front. Well, it's you don't the motherboard goes in the computer, and but I have my case came with a front panel, and that connects to the motherboard to be able to allow me to use USB in the front of my computer. So you get the idea. If you've ever built a computer, you know what I'm talking about. Now, the power supply. The important thing about the power supply is you really don't want a power supply that is exactly the same size as the stuff that's running inside your computer. So if you have, let's say, 500 watts of power that you're using for your motherboard, CPU, all the hard drives, one or more, and your let's say you have um, RTX 3080 video card that takes 250 watts or something to that effect. Well, if you have 500 watts and you have 500 watts worth of stuff, then unfortunately, just like you're going to get these things called ambient spikes, where when something comes on, it uses more power than it ultimately uses after it's been on for a little while. The same thing happens with your refrigerator, your freezer. I'm not sure about an oven, but a generator, any kind of generator, when you first plug it in, that's when you blow the circuit if you have other things running because of that. The AC has a spike at the beginning and then it calms down after it's on. So anyway, the same thing happens with the computer. So if you have 500 watts of need because of the parts that you put into the computer, you really should buy a motherboard. I'm sorry, a power supply. I like to go with a factor of 50% more. Some people say 20% more, but if I have 500 watts in my computer, I'm going to get a 750 watt power supply or more just for future expandability and to be able to avoid those spikes. Anyways, that 50% is not an official. It's just what I go with, and I've avoided problems in the past because of it. I have had problems where my computer used as much power as what I had for a power supply, and what it would do is I'd just be going along working on something, and I would open up something new. I would turn something on, and the computer would just turn off. It would just turn off. And what's happening is the motherboard or the CPU through the motherboard is identifying that there's a power shortage and it turns itself off to protect itself. You want that, but it's really frustrating when all you did was, I don't know, start something on your computer, um, and it happens right when you do something. You'll start something, computer goes off, and that's because of it. So I upgraded my power supply, and that problem went away. Now, how much power is enough power? Enough power, and you need to have enough power and proper cables for video cards, number and type of power cables, SATA, Molex, PCIs, and fan to be able to plug all the stuff that's in your computer. The form factor we talked about already, but even power supplies come in different form factors. And you got to make sure that the power supply fits in the case that you have. Wattage for the 12-volt line. Total wattage is the key. Using an online power use calculator. I have a power strip that I actually plug my computer in, and it tells me exactly how much wattage my computer is using at any one time. So I use that to gauge the size of the power supply that I need. Quietness. And quietness when it comes to a power supply might mean that, and this especially is true if you go with the 50% more and you buy a power supply that turns itself off instead of when the fan's not needed, the fan turns itself off. Maybe you're not gaming, for example, and while you're not gaming and you're only using Word, you don't use as much power, so the fan actually turns off. It makes your computer a little bit quieter. Now, on the other hand, when you start gaming, it'll kick back on again to help cool the parts in the power supply because it's providing more power to your video card. Now that again, if you have a power supply, let's go crazy, right? Let's buy a 1,000 watt power supply for only a need of 500 watts. Well, that fan is not going to come on maybe ever because your power supply you're not even using 50% of your power supply at most times. So if quietness is important to you, then maybe buying a power supply that's twice as big as what you need is important. Now it's going to use the same amount of power because you're just pulling 500 watts, whether you're pulling it from a power supply that has 1,000 watts, or you're pulling it from a power supply that has 500 watts, you're still only pulling 500 watts. So the only difference between 500 watts and 1,000 when it comes to the amount of power being used is very minimal, and it's the cost, of course, is higher for the 1,000-watt power supply than for 500 watts. So, but the use voltage is the same. I mean, when you're looking at a power supply, you want to check the different codes, whether it's gold or platinum. Most power supplies are gold or higher today, although you can get a bronze one. I don't recommend it. Take a look at those. I don't think that's not in the A plus certification, but the different power supplies have different, um, uh, not only different the quality of power and the mean time between failures, MTBF, but it also has different warranties, how long they're going to last. They also, all power supplies should cover you for overcurrent, under voltage, and short circuit protection should be built into all of them. They show some power supply case design, a table here that just talks about what you would need for different types of computers, because we already covered the type of computer. So if you're using and they just recommend it. And this, again, this is probably A plus type thing. But if you have a graphic cam, a cam CAD, gaming PC, home server, audio video editing computer, visualization computer, you want 500 watts or more. You need an ATX mid or full-size tower and 2 or more cooling fans. Thin client, 300 watts, or they call it they just say a high power supply, right? 300 watts is a pretty small power supply. You can still use a higher power supply, but 300 watt is the minimum. Mini ATX, because you're not pushing a whole lot of connections. You have 3 connections, one to your mouse, one to your keyboard, one to the internet, and one to your video, your monitor. So maybe 4 connections. You probably don't have a whole lot more than that on just a thin client. Thick client, 300 watts or more, ATX, mini ATX, or micro ATX. Those are sizes of motherboards. Make sure to look that up and have an idea of what size they are. And then the size tower, the tower should be able to fit. Like an ATX tower fits the mini ATX, but it's silly because a mini ATX is really small. I guess I should hang on a second. Let me bring that into the video. 1 second. All right. So here are some different size motherboards that I was talking about earlier. You can see it would be silly to buy a case that holds a extended ATX motherboard that's 12 by 13 if you only need 6.5 by 6.5, 6.7 by 6.7, right? Yes, it would probably work. Yes, there are probably holes. Before you buy the case, make sure that it does say that it supports a mini ATX or macro ATX. But ultimately, these are different size motherboards that gives you different capabilities, right? So the mini ITX is probably perfectly fine for a thin client, but you wouldn't want to run a gaming PC off of this. I know some of you out there are saying it works perfectly fine, but it wouldn't be preferable. It'd be better to have a full-size ATX or an extended ATX to have more connections for multiple video cards, for example, than it would be to try to run it off of an ITX. All right, let's keep going with this. And all right, and yeah, here we go. Keep going. Make sure that I'm recording. I am good. All right. So, and then there's the video, the motherboards. All right. So storage, we're talking about SSDs or hard drives. Use magnetic or flash technologies for internal or external hard drives. Flash storage, including SSDs and M2 drives now in today's world, or optical drives. When adding, replacing, or building a storage subsystem, you must take into account the customer needs, how long the customer plans on storing the data, and how long the customer thinks the storage system will be in use before being upgraded or replaced. again, how long will the computer last? If you're replacing a hard drive in an older computer, you may not want to put um, may not be able to put today's newest technology. For example, there may not be an M2 slot in a computer that's 5 years old. Matter of fact, there probably isn't. So you might have to go with the SATA hard drive. But if there is a slot in there, why not upgrade to M2 if your SSD goes bad, and that way, if you replace the whole computer down the road, you already have the M2. You can move it to the new computer. That's the newest standard for SSD technology. Here they show you storage, including the way it connects. An M2 slides into a slot that's on the motherboard. SATA, we've talked about before, it's a port on the motherboard with a cable that runs from the motherboard to the device. Molex of SATA power connectors. Molex, mainly you only see those for fans in today's world, but if you're working on older computers, you'll see Molex connectors. They just can carry more power. That's why they are still used for fans. Internal physical size, 1.8, 2.5, 3.5, or generally hard drives are 5.25. I haven't seen a SSD at 5.25 ever. I don't even think they exist. With available expansion slots in the case to be able to put that hard drive. External connectivity, how is it connected? If it's outside your case, as I mentioned earlier when we were talking about the RAID cabinet, is it connect by USB? IEEE 1391, that's called FireWire, eSATA, eSATA AP. eSATA is just a SATA connection that is on the outside of the computer. It actually has a different connector, but it works at the same speed as your motherboard's SATA connection. So if you're at 6 gigabit per second, or 6 megabyte, I think it's 6 gigabit, then the eSATA would be at the same speed inside or outside. NIC for your connection, your speed, well, you might have a RJ45 Ethernet cable connecting your external storage to your router, your switch, or the back of your computer, possibly. If you have multiple NIC connectors, you might be able to do that. If required for cloud or internet storage. That way, when you're at work, if you have access to it with the right software, you would be able to access your hard drive externally. That's nice, but you got to be aware of security as well if that's what you're doing. External power, either external power cord or power provided by USB, IEEE, FireWire, or eSATA. Your power is, if my Mediasonic external RAID cabinet came with the power cord. You plug it in, you plug it into wall, you're good to go. Most likely any type of storage subsystem, an external hard drive, if you will have its own power. You don't have to worry about purchasing additional equipment. Storage technology. Now, we've already covered all of these, but let's go over them. We got magnetic, that's a hard drive, or optical. We have SATA 1.53 or 6 gigabits per second. There you go. And it's SATA 1, 2, or 3. M2 flash memory, that's like your USB drive. And hybrid, that is a hard drive that actually has SSD built into it. And that's so you have quick access to information you use on a regular basis. Consider it sort of a buffer. That's what that's used for. And it's great for if you only want to have one one hard drive on your computer, and you want it to be a big hard drive. Buy one of these hybrids, and the SSD portion of the hard drive allows your motherboard to quickly access your operating system to quickly access the SSD files for your operating system, But then when it needs the bigger files, there is plenty of space to load movies and whatnot. And it doesn't need as fast a connection to movies as it does to the operating system files. Uh, and they talk about speed, uh, 5400, 5900, 7200, 10,000. I had a 10,000 uh, uh, drive, and it was RPM, 10,000 RPM. It was so loud, I never even considered it. Now, most of my drives are 5,900 or 5,400. Slower, it doesn't make that much difference when it talks about access speed, but it makes a difference when it comes to power usage and the sound, how loud it is. If you guys disagree with me on that, again, you can make comments down below. Tell me what your experiences are with 10,000 RPM drives. For me, it was super loud, and I would never buy one again. I can't even imagine how loud a 1,500 RPM drive is. Let's see. Input-output operations per second, IOPS for magnetic drives and SSDs. Now, you actually see that. That's a critical element. When you are shopping for an SSD, you want to, it's the measurement of how fast it can read and write onto the drive. And that's critical. Well, don't just buy an SSD that's, say you're buying a, a big SSD for your computer. Let's say it's 500 gigabit or 1 terabyte SSD. And that SSD, compare it to other SSDs of that same size. The price point isn't the only thing you want to look at. It's how fast can it read and write. There's a big difference between different SSDs, and you want to look at the the IOPS to see if it's, maybe do a calculation for IHOPS per dollar, something like that. I don't know. But anyways, optical drive, you can either buy a read only or read write. I don't know anybody that's buying CD drives for computers anymore, but you may need it for some reason. And if you do, make sure that you buy a compatible drive for your system. It will connect to SATA port, maybe a Blu-ray, right, with a blue laser, or the older ones. Make sure that it's going to last. If you're going to put it in there, you might as well make sure you get one that can read and write everything today, right? Drive buffers. Both hard drives and optical drives can have buffers. I talked about that a moment ago when we were talking about the hybrid hard drive. And external considerations. What other devices may share the port, the external cages, enclosures, if needed, to turn internal devices into an external drive. So at one point in my experience with computers, I bought, instead of buying an external hard drive that cost more money, I bought an external hard drive enclosure, and then I bought the hard drive that I wanted because I could buy a bigger hard drive to put into the enclosure than what I was buying as a combination. And I saved money, and I got exactly what I wanted. So you can buy external hard drive enclosures that hold one or more hard drives. The Mediasonic, that company I talked about earlier, for my RAID cabinet, actually sells not a RAID cabinet, but they sell an external hard drive cabinet that all it does is allow you to put 4 hard drives in there or 8 hard drives in there. They don't RAID. So if you want RAID capability for backups, well, to be able to protect your data, make sure you buy a cabinet that allows for RAID, because if you don't, you're not going to have that capability, right? Other concerns or considerations, audio. Most audio is built into the motherboard, but you may have a computer where maybe it's old enough it doesn't have sound built into the motherboard, or maybe the sound in the motherboard has gone bad. Instead of replacing the motherboard, you can add a uh, a um, a sound card to the computer using a PCI slot or whatever slots are on your computer. Make sure before you order a sound card, make sure that you buy the right card for the right slot, and you have a slot that's available. The card has ports for for speakers and for microphone. And I know we covered that in this class earlier because I remember telling you that you have to know the different colors. Um, it says I've actually helped a client of mine, one of the clients that I tutor, helped her choose some speakers because she had no sound in her computer, and literally no sound. And she said, "Hey, I'd like to hear sound." I said, "You have no speakers," and she said, "No." So we bought some nice speakers. They were not expensive, and she loves them. And she actually uses a computer for music in her living room now, and she didn't do that before. So, anyways, it helps if the customer can actually listen to the speaker. But in today's world, kind of hard to, if you're buying it online, you could have them go to a local computer shop and listen to it, or maybe a local, maybe Walmart or something like that, and listen to speakers. But ultimately, uh, they all plug into the sound card, so it doesn't really matter. Probably doesn't matter what speakers they buy. I know again down below you're going to make comments saying it does matter, and it probably does, but most speakers, if it has a if it has a connector, it's probably what is it, a BNC mini BNC connector. So it's going, don't buy a Blu-ray speaker if you don't have Blu-ray on your computer. You should know that, but maybe your client doesn't. I don't know. They talk about the difference. Here they're talking about um, size aspect ratio, and they're talking about um, the table here is talking about video. The But they don't actually talk about video on this slide. Oh, they do there, installing displays. Okay. So you have to be aware of the aspect ratio. And I wasn't really aware of aspect ratio when I first started buying my computer because I went with 16:10, and that's not the standard. Standard gaming is 16:9. And so when I play games, I have this 1 inch border above and below my screen. I'm okay with that. I have a bigger screen when I'm working, but gaming, it actually, you probably have seen what the aspect ratio issues when if you've bought a large screen TV in today's world, maybe a 55 or 65 or 85-inch TV, and it's not the same aspect of the video you're playing, the movie you're playing, and so it blocks out. It gives you a block at the top of the bottom. You don't want them to stretch the screen because then people will be taller and skinnier. Maybe that would be better. I don't know. The game would be everything would look taller and skinnier. I don't know. So you actually, it's better if they put the block on the top and the bottom. It's just a black area. It doesn't really bother you. It doesn't bother me. But I probably would have gone with 16:9 if I started. That first monitor I bought so many years ago, it still runs. So I still use that 16:9 because I had that one and it's still run all these years. I bought three more of the same ratio, so that's what I have locked into. But you have to be aware when you buy it. These are just some of them. Widescreens could even be wider than that. Number of screens, you can have two or three. The screens. My computer actually has the capability with the graphics card that I have that I can actually stretch my screen when I'm playing a video game. I can actually stretch my screen so it fills all three. Picture a driving game, driving a car on a racetrack, and just like in a real car, you can look right or left. That's what it feels like when I'm using that capability. That's a capability of the video card, though, not the screen itself. The types of display. They talk about plasma here, but plasma is not a real thing anymore. Some people still have plasma. I'm not making fun of you, but it is a technology that they no longer make plasma TVs. So you're not going to be able to go and buy a plasma TV or monitor. Maybe one used on eBay, but the technology had a problem with burn-in, and then I think they fixed the problem. Ultimately, they fixed the plasma burn-in issue, but people just in the back of their head, they just thought plasma, I'm not buying it, has a burn-in issue, even though they solved that problem. Ultimately, if something was on your screen for a long period of time, it would remain on your screen even when you moved it away. It's not a good thing. LCDs with CCFL backlight, LCDs with LED backlight. That has an LED back there, and OLED TVs which are organic. You want to read up on the different types of displays before you buy a display, because it really makes a big difference. It's also a big difference in cost, beyond the scope of this presentation. But don't just buy a TV that's $200 compared to the one next to it that's $2,000 because of the price. You might want, if you can afford it, you might want that $2,000 computer, $2,000 screen, because of the capabilities. Different displays cost different prices because of the quality. Often the quality is different. How does it connect? Is there an integrated microphone and webcam on your monitor? The contrast ratio, a higher number appropriate, number appropriate. Keep in mind that not all vendors give true numbers, and what they're saying is buy the highest contrast ratio as you can for the cost. Size is the same issue. What kind of connections are there? The video adapter, the slot type, the number of ports. Is it does it have HDMI ports? Does it have, I think, no, are they talking about video here? Let's see. No, they're talking about video here. I'm sorry. It does apply to the monitor you're buying. Make sure that if you connect through DVI or HDMI from your monitor to the back of your computer, make sure you buy the right, obviously, a monitor that has the same connector. Although they do have DVI to HDMI to DisplayPort adapters, you're better off buying a native a monitor with a native port. So if your video card outputs HDMI only, you want to buy a video card that has an HDMI port. Now they're talking about the video adapters, that actual video card that pushes your display. Now, video does come built into many motherboards, and it's perfectly fine for a home PC that just uses Microsoft Office. But if you're using it as high-end gaming, you would want more RAM in it. You would want capability for Crossfire or SLI. That's where you're connecting multiple video cards together. You want to have the right kind of ports on it. DisplayPort has an HDMI, have higher resolution than VGA. Anyway, so and then of course your power supply has to be able to support the power and cooling requirements for that video card, and the connectivity, right? Is it a PCI video card? Today's world, they probably are PCIe video cards, but is it X1? Is it X4 or X16? Is there an X8? I don't remember off the top of my head, but make sure your motherboard has the right kind of PCI to support the video card that you're buying. That X makes a big difference. The X number. Troubleshooting. All right. So one essential trait about troubleshooting, the will to succeed. And what that means, I like to think that computer technicians are no different than computer users. The only difference really is we will not give up. We will find a way to make it work by trying different avenues, or heck, trying the same thing multiple times. What is it? Freud once said, is it Freud? Einstein said the definition of insanity is to do the same thing multiple times, expect a different output. Well, something to that effect. I'm paraphrasing. But a computer technician knows that trying the same thing multiple times might ultimately fix the problem. I know that sounds weird, but it's so true. I can't tell you how many times I've done the same exact thing 3 times and have it work on the 3rd time. Sometimes it's because we just went about it maybe we restarted the computer, then we tried it a 2nd time. Maybe we disconnected a port and then reconnected the port and tried it again, like the mouse, for example, right? I can't tell you how many times I've disconnected my mouse and reconnected it just to reset. I don't know why, but I just reset the mouse and something changes and it works the way I expect it to. that's not a great example, but you understand. Even just steps, going through steps, trying it a second or third time, a computer technician will try it a second or third time, and it'll work on the second or third time. And you'll be like, hey, there you go. And the person that you're helping is like, well, I tried that. And it's like, well, did you try it 2 or 3 times? Anyways, um, different ways to do different things, different ways to access different tools. Like you can get to the device manager by typing device manager in the search box, or you can go to settings, or you can get to device manager by going to computer management, the management console. So there's lots of ways to get to different places to try to make changes, and as a technician, you should be familiar with all of those ways to get to places and all of the available resources that are available to you to help troubleshoot problems or technical problems. Local troubleshooting can be broken down into 6 simple steps. Identify the problem, establish a theory of probable cause, question the obvious, test the theory, establish a plan of action to resolve the problem and implement the solution, verify full system functionality, and if applicable, implement preventative measures, and then document. All right, so let's go from the top. Identify the problem. Sometimes you won't have the help of the user to help you identify the problem. It'll be obvious. You'll walk in and the monitor won't be on, and you'll look for possible problems. Is it disconnected? Is there no power in the wall, et cetera, et cetera? You'll start troubleshooting that problem. Sometimes you'll have somebody available that reported the problem. Well, when that's the case, ask them and listen. Don't interrupt. Let that, going back to the irate customer at the beginning of the presentation, let the customer explain what happened. Ask them open-ended questions. Well, what was going on when this problem first occurred? And let them be honest. Don't judge them when they're talking to you. You know, when they say, "Well, I was drinking, I had a sip of coffee, and then I put the coffee cup on the computer, and then it spilled on the computer." Don't don't judge them, okay? Just fix the problem. And then at the end, when you're documenting your solution, you might mention to them having a coffee cup next to your keyboard or on top of your computer case is probably not a good idea, right? Leave your drink on the floor or on a different table. That way, this doesn't happen again. But not at the beginning of the problem. If you explain, if you chastise them at the beginning, then they're not going to be open and honest with you. If something else might have been the problem, not the cup of coffee spilling. Okay. So once you identify the problem through, how was the problem found, and what steps have the user already tried to do to fix the problem, then you will, from experience, you will establish a theory of probable cause. And there will be multiple possibilities. Like I just said, for a monitor not coming on, it could be the power is disconnected by the back of the monitor, it could be disconnected from the wall, it could be that the circuit breaker is gone, it could has tripped, it could be that the it's not turned on, it could be that the monitor itself is broken, it could be the video output to the monitor, it could be not putting output video. A lot of possibilities for something as simple as the monitor is not coming on. What I'd like to recommend is test the easy ones first, right? Check the plug in the back. Check the circuit breaker, right? Those are easy. Um, Restart turn off, check the power, right? Turn it off, turn it back on again, see if it comes back on. The user might say, "Oh, I've already done that," but go ahead and it says just going through my checklist, and go ahead and turn it off, turn it back on again, and make observations. The reason I say go with some of the easiest things to check is because you don't want to jump to replacing the monitor, right? So you don't want to jump to replacing the monitor. It could fix the problem because maybe you had a loose cable, you replace the monitor with a new monitor, it fixes the problem because the cable's plugged into the new monitor, right? So you don't want to jump to something that that creates a lot of hardship. In my Cisco classes where I teach um, uh, troubleshooting in that class, you don't want to just restart the router. In a PC at home, restart the computer, see if it fixes the problem. But a router, especially an edge router, where the entire company is going through that edge router to get to the internet, you bring down that edge router, and it's going to you bring it down. It's going to bring down the entire company's ability to get to the internet and the internet's ability to get to the company. So it's a major thing to restart a router. So you need to do some easier things, maybe not not as obvious things as just restart it, but things that won't be uh, so damaging. I'm losing the word here. Impactful, right? You don't want to impact the whole company just because you say, "Well, restart the." They'll get tired of that. If every time you have a problem with the router, you just restart the router, they'll get tired of that. Okay, it's off again. No, I'm just restarting the router. Don't do that. Test the theory to determine the cause, obviously. Check the power switch, check the cable in the back, check the wall. Establish a plan of action if you have to replace something like a new monitor, a new video card, um, a new circuit breaker, I don't know, and implement the solution. Verify full functionality. Now, they say full system functionality here because you need to make sure that you have solved the user's problem. Whatever the user called you, you want to make sure that you fixed that problem. You may have fixed other things. I can't tell you how many times I get called in to help fix a problem. And I fix this and I fix that and I fix this because all sorts of little things I notice when I'm at somebody's house tutoring them. It's like, oh, you don't have a picture of your dog in the background of your phone. You should have that. I actually did that once. And the student and the person I was tutoring loved it. They were like, "Oh, thank you so much." But that wasn't why they asked me to come to their house. I was just goofing around and I put a picture of their dog. They had never taken a picture of their dog with their phone. I don't know why, but that's why maybe I'm the tutor. I don't know. But anyway, so they loved that and they were so happy about that. But anyways, make sure you ask them, did I solve the problem that you called me on? Right. And I love it when online tech support says, is there anything else I can help you with? I just love that. Now it might extend your call. If you have a number of other things that you have to get to, you have to be cautious with that statement. But if you have time and you want excellent customer support, you want to be known as the person that provides excellent customer support, then a great way of avoiding irate customers is to say, after you fix the problem, did I fix the problem that you called me on? And when they say yes, then say, great. Is there anything else I can help you with? And hopefully they say no, thank you so much, and off you go to the next call. Sometimes they'll say, well, can you help me with this? Heck, it saves you a drive out to that location or another call from the customer, which will down the road help alleviate other bottlenecks of troubleshooting where multiple people are calling you. Go ahead and solve as many problems as you can when you're there, especially if you're not in a time crunch to do other things. I know we're always in a time crunch to do other things, but you get the idea. Documenting is critical. Now, I know most of you probably don't think it is, but I'll tell you why it's so important. So, in a corporate environment, at home, you can probably remember what the problem is and how you fixed it. So, if it comes back again, you can fix it again. But in a corporate environment, when you have a problem and you fix it, you need to have a change log that is located next to the equipment. And in that change log, you need to put the troubleshooting finding, what the problem was, what you did to fix it, and um, recommendations for the future. And the reason why you want to do that is because let's say you have a router, and on the router you have a serial card plugged into the HWIC port, the WIC port, and the and and that interface card goes down. And you put another interface card in there, and the connection comes back up, and everything's fine and dandy, and you leave. And a week later, the interface goes down again, and another technician goes out, and they replace the HWIC card, and it brings the system up again. And another week goes by, and the connection goes down, and another technician goes out. Your IT department has 20 people working for it. Another person goes out, spends an hour troubleshooting, figures out it's the WIC card again, and replaces it. If nobody writes it down, nobody will realize that there's an ongoing problem of something causing the WIC card to go down. The router itself might have a problem where it's causing the serial card interface to go down. That same thing could be true with the monitor that goes out. I don't know. Maybe a video card is somehow frying monitors, and people are just replacing monitors. Or maybe you replace the video card, and the computer, works for a little while, and then the video card goes out again. Maybe the motherboard's the problem, not the video card. You keep replacing video cards, but the motherboard is causing the problem in the video card. You get what I'm talking about. So it's important to document what it was that was the symptoms, what you did to fix the problem, and then any recommendations for the future. So a recommendation underneath could be something to the effect of, keep an eye on this computer. It's the second time I've replaced the card. Or I know that it's the third time we replaced a WIC card. We should look into upgrading the router if this happens again. You get what I'm talking about. So documenting is critical to being an efficient organization that doesn't waste a whole lot of time sending multiple people to fix the same problem over a period of time. Also, heck, even if that WIC card isn't being burned out by the router, the next person that goes to see looks through the documents. Oh, all they did was replace the WIC card. Let me try replacing the WIC card and see if that fixes it. Oh, fix the problem. Great. Document it. Off they go. And maybe you just you bought a bad WIC card to go in there. If it never happens again, you just saved an hour of troubleshooting for that second technician. I think you get the concept. But these 6 steps can be used for troubleshooting any problem in technology. Heck, probably any problem, just about any problem in life, right? I'm not going to get into how to use the troubleshooting overview, these 6 steps to solve relationship problems, but who knows? Maybe you could use them to solve a problem in a relationship. Maybe you could use these with a problem with your car. Maybe you can use these with your lawnmower, whatever. You get the idea what I'm saying. These are good troubleshooting tips and steps to take so that you can avoid problems down the road. All right, that's troubleshooting. All of this comes from the complete A+ guide to IT hardware and software from Cheryl Smith, Professor Smith, and it is for the A+ certification, the 220-1001 and 220-1002 exam. That exam is being replaced in the spring of 2023. So if you are at the end of your hardware course now, if you've already taken the software course, if you're taking it concurrent with me, make sure that you go take that A+ cert test, right? Do some studying online. Go take the A+ cert. If you are in the fall, let's say you're taking this in the fall, you need to take it immediately. So hopefully you're not taking only this course, your first course in the fall, because you probably will miss out on the exam. Check the dates for when that exam goes live and when the 220 is retired, because you don't want to study for the wrong exam. Anyways, that's it for today's presentation. Again, it's been a pleasure helping you. My name is Don Lafont, Professor Don. If you're here with me live, just hang out a couple minutes. I'll give you an opportunity to ask questions. It's been a pleasure helping you to learn about A+. At this point, you don't know everything. I'll be honest. I didn't go into detail on a lot of things because these presentations are to give you an overview of the concepts. There's a fantastic teacher that I learned a lot from when I went through my A+ certification. And I'll give you I'll give him a recommendation right now in my own video because he helped me earn my certification. So I'm going to have him help you. His name is Professor Messer. I'm going to pull him up right here. And I'm going to share my screen again. I apologize for jumping out. I wanted to do this beforehand. But let me share my screen. Where is it? Here it is. Share. I'm going to share this guy with you because he helped me get my A plus certification. Now I've been through the A plus class. I took the A plus class. Afterwards, I went through his 65 videos. I think there's 65 videos. Let me see. Let's see if I can see that. I can use my glasses probably. But this guy, he's a professor, and or at least he calls himself a professor, and he is fantastic when it comes to um, he's fantastic when it comes to learning A plus. Now he made two playlists, and the A plus. One of these is software, one of these is hardware. Let's see. I don't know which one's which, but there are 74 videos in one and 68 videos in the other. I highly recommend watching all 64 videos before you take the hardware. 2001 is hardware. So 74 videos before you take the hardware class. Watch every single one of them. They're gonna take you further in depth in the study topics for the exam. And then when you go to take the software exam, watch the 68 videos for there. You have to pass both of these exams, 220 1001 and 220 1102. Is that a typo? A thousand. Here, this is it. This is the 1002. This is the A plus. I don't know what that is. Anyways, these two, this one, 74 and 63. You need to go through both of those. I recommend going through all of those videos. I do. I did, and I'm a teacher at a college level, and I took the class, and I went through every video. I passed my A plus on the first time through. So with my videos, the videos that you just went through, my videos, hopefully you've watched them all. Those videos will give you a broad overview, so then you can go to the next step and learn more specific. If you just jumped right into Professor Messer's videos, you probably won't. Some of the topics you're not going to understand because you're not going to understand where they connect, if you will. But through my videos and his videos, you'll pass that A plus. I promise you will. Let me know, by the way, when you pass your certification. Let me know. Put your comments down below. In this video, it's a perfect one to do it. Just come here and say, I passed my cert. Thank you so much for helping. And I love seeing that. Of course, I also like you to like and subscribe to my channel so you'll see future videos. Maybe you'll go into the Cisco certification CCNA cert next. And I've made videos for all of those. But I highly recommend just spending as much time as you can in a short period of time. Go take the exam. If you just finished hardware, go take the hardware exam. Don't wait for 12 weeks from now, 16 weeks from now, when you finish the software class to go take the software, because hardware is fresh in your mind right now. If you wait for the end of the software class, you're 16 weeks away from hardware, you're going to start forgetting it. You're not going to be as confident. So if you can, go take the hardware class. Watch his 68 videos, 74 videos, whatever, and then go take the hardware class. Then go take the software class with me if you haven't taken that yet, and or watch my software videos, and then go watch his software videos. Anyways, so hopefully, I'd love to hear when students pass their certification. So hopefully you let me know when you do. And even my YouTube audience, I love when you let me know that you passed the certification and that I helped in that process. It makes me feel good, and it also motivates me to make more videos. All right, that's it for this video. I went a little bit over. I apologize for that, but I hope you appreciate it. My name is Don LaFont, Professor Don, and I will see you not again in this class, but I'll see you again in A plus software if you're taking that next. And hopefully in some of my other videos are helpful for you. But thanks for coming to class. I appreciate it. Have a great day. Good luck. And good luck when you take your certification. I know it's very rewarding when you can finally put your arms up and say, yes, I passed. Like I did yesterday to my CCNA certification. I took that test finally after talking about it for years, and I passed it on my first shot. So I'm very happy that I am now CCNA certified. But anyways, great. Thanks for coming to class, and I'll see you again soon.